me share my screen. Okay. So this topic is on coverage collection to see how can we switch on the coverage collection and how does it look like on visualizer. So later by the end of this topic, we'll also have do one lab case on coverage. So let's begin. So this is on coverage collection, and most of the DV, they will do a code coverage collection, and we have a lot of requests on coverage collection from them as well. So these are the common types of coverage. So on functional coverage, we have a verification plan. And for code coverage, we have all of these different code coverage that can be switched on. So such as S for statement, B for branch, and then we have condition, expression, FSM, toggle for 2 states, and X toggle for 6 states. So all of the options except for X will be applied when plus cover is used without any options. So plus cover is default to BCESFT. So branch, conditional, expression, FSM, toggle, and also uh, oh, yep. And then for both functional and code coverage, we'll measure the completeness of verification. So in terms of coverage, we will generate this UCDB, Unified Coverage Database. So it includes all of the code coverage, functional coverage, assertion, test specific, user coverage, and also test plan in one unified database. So it's called UCDB. So we also have this system verilog cover group coverage, verification plan, links between this verification plan and also coverage data, system verilog assertion coverage, user-defined data, and also the test data inside. So what's the example of functional coverage? So functional coverage, or we can also known as cover group, defined in the test bench. So for example, if you define your cover group and name it as CG, and then all of your cover group definition will be in here. And then you can also see this cover group actually from our debugger visualizer as well. So on debugger, we have this cover group window, and then you can see, let's say, for example, your cover group name CG here, and then you can see all of the hit and miss bin in your cover group itself. So more on functional coverage. So this is the verification plan from the design specification. So verification plan for your concat design. So for example, if you want to do it in Excel file, you can use XML to UCDB format. And then you can input your XML format, and then you can output your UCDB as shown in this slide. So it will output this UCDB test plan tracker here. For code coverage, in specific statement, so statement are portions of the code that can be executed, meaning that they can produce an effect on the simulation. So for example here, if you can see the code coverage by statements by instance, you can see the line number of the statement and then how many of these statements are being covered and why is it not being covered here. And from this coverage report, you can also see how many bins are there in the statements, how many hits in the statement, and how many misses, and the total coverage percentage for this statement. For branch coverage measures the expression. For example, the if-else statement and case statement that affects the control flow. So if you can see the code here, there's a if-else statement here, and this branch coverage will measure how many percentage are being hit in this if else statement. So again, on the coverage report, you can see the instance, branch coverage and the DU. Then how many bins from this branch? So for example, 1, 2, 3, 4, 5. So 5 bins and then 3 hits and 2 misses. So which line will it miss? It will also be reported in the coverage report as well. For code coverage in condition, so condition coverage analyzes the decision made in if and ternary statements and can be considered as extension to branch coverage. So let's see where this branch coverage are being covered. So line 14, 16, 18, and 20. So for example, line 14, 15, 16, 18, and 20. So this is if, else if 6, 7, and 8. So this is the value that always I is. So input term I equals to 7 is not covered. And the total of different values of I is 4, so it's covered by 2 and it misses by 2. And for FSM, you can list out FSM to draw, and you can see how many counts are being hit here. You can toggle this transition state counts on and off. If it's too messy, you can toggle it off, and then transition conditions, time display, wave cursor tracking, and you can animate the diagram over time as well. Uncovered states and transitions are highlighted in red. So for toggle code coverage is the ability to count and collect changes of state on specified nodes for various Verilog system, Verilog, and VHDL signals. So that for this Verilog and SV, so for example, wire, reg, bit, enum, all of these real, short real, and integer atoms, you can actually see what kind of toggle are they covered. So for example, if it's from 0 to 1, it's high, and then it's from it's 1 to low, 1 to 0, it's low. Or if there's any extended 6 state, you can either change from Z to 1 or 1 to Z. And for code coverage in terms of expression, this is just to analyze the activity of expression on the right-hand side of assignment statements. So for example, let's say right-hand side assignment statement is compared error, and then you assign it to descramble XOR RXD. So this is not being hit, but this is hit here. And further in on the coverage report, we can see what are the rows and the non-masking conditions that we should hit so that we can have the hit condition fulfilled. So on coverage text report, so as previously, we always look at coverage text report because it's a very simplified way to look at coverage if you don't really want to bring up the debugger. So here, coverage, you have your coverage report and also your cover group report. You can view it. So on Questa coverage collection, so how do we enable this coverage collection? By default, coverage collection are off, so we have to enable it ourselves manually. And on the functional coverage, it is enabled automatically. We can disable functional coverage by adding add -no CVG in the vsim command. So code coverage enabled in compilers or optimizer, you can use the same compile option, so either vlog or vcom. And in your optimization phase, you add a plus cover. So for example, if you are compiling all the files in .f file, and then you use optimization vop top dash o, and then your optimized DU name. And then in the same line, you can also do plus cover equals to the code coverage that you want. In this case, it's statement, FSM, and also toggle. In vsim, you can simply just add the minus coverage. So this will start the coverage collection. So this is just explaining the same code coverage options that you can use in VOP. So just now we are using S, F, and T, so statement, FSM, toggle. But you can also collect a branch condition and expression, as well as extended toggle. So to dump specific instance instead of all of the instance that you want, you can also specify the instance by using plus cover and your coverage collection plus the instance that you want. You can also use dash toggle ports only. This is to only collect toggle coverage for in-out ports. So all of the wires and reg are not being covered in this toggle ports only. To save this coverage collection for a single test case, you can invoke vsim with dash coverage, and then you can generate your UCDB file within this do file. So in your do file or your do command, you can add coverage save on exit, and then your UCDB name. Then you run all and quit. When it comes to regression, we have a different way of saving, because in regression, we have a lot of different coverage data, many UCDBs for each test case. So we invoke vsim with cover store and the test name option so that we can automatically save the coverage data at the end of simulation. So this cover store will have the test name associated to it. And the design hierarchy and the directive path in the cover store arguments must be the same for all the simulation runs in a regression. So this is the example. Right after the regression, we should be able to merge all of the coverage data accumulated in cover store using the path in the directory as the input to the merge. So we can merge the UCDBs from the directory using vcover merge minus out. So this is your merge UCDB name, and then your cover store directory path, and it will automatically merge all of the UCDBs in the directory path. So if you want your coverage report generation in text form, you can use this vcover report and your UCDB name and dash output your report name. So this will dump local coverage result to your run directory and named as your output name. For recursive coverage result, you can use the cover report, your UCV name, output, and your coverage report name, and also the additional of minus recursive option. So this recursive option is to view bottom-up coverage collection. So if you can see the difference between the local and recursive. So on the instance bit controller and the design unit master bit controller, and the difference at byte controller where it is one instant up bit controller. So on local coverage, byte controller will only allocate the counts of local bins and also local bins without the coverage collected from the bit controller. But for recursive, byte controller will include the coverage collected from bit controller to add up to its total hit. There, if you can see, if they add up, so the local bins are only 43 at byte controller, but the local bits at bit controller is 71. So if you add these two up, it will be end up 114 total bins for this byte controller and also its bit controller. For statement and toggle only, you can also specify it with recover report, your UCB name, output name, and then your dash code ST. So this will only record statement and toggle only in your coverage report. And if you want to view it in HTML instead of Word form, you can also use HTML report as well. So it's the same. You use VCAL report, your UCB, but this, your output, you put uh, your output name minus HTML. So you can open up this HTML report with Firefox. So Firefox, this HTML report, and then you can see the interface of this report in HTML form. So how does it looks like in visualizer standpoint of view? So to get it started, we need to generate UCB file using the code or functional coverage enabled. And then we'll open up the UCB file in visualizer viewCAF mode. So for example, if you prompt visualizer minus viewCAF and your UCB name, you will be able to invoke this UCB in visualizer so that you can navigate it around. So usually from visualizer, if you use viewCAF, you will go to view and coverage, and then it will show you all of the coverage details that you can see. So for example, you can see the DUs, coverage summary, code coverage outline, coverage details, cover groups, assertion coverage directive, FSMs, total coverage, even exclusion list as well. On the summary window, this is the main window that we'll be seeing a lot because every coverage, code coverage that you specify will be here. So for example, the assertions, branches, condition, cover group expressions, statements, and toggles, you will see the total coverage for each code coverage here. And this coverage summary is updated dynamically in coverage summary window. You can do a quick analysis of coverage type contributing to the list total coverage, and you can double click on the graph to navigate coverage types detailed debug page. So once you double click, let's say for example, you double click on this cover group, it will bring you to the cover group window. From the cover group window, you can again double click on this to see the cover groups and also the crosses. So you expand the cross to see the holes. Where is it the bins not getting hit? And you can see the problematic cover ports bins contributing to 0. So you have to check on this. Why is it not being hit? And then you can increase your coverage count from here. You can also exclude these bins using a right mouse button. If you just click a right mouse button on here, you can easily exclude this from the coverage calculation. So once you have excluded any of the signal, you will see it will be grayed out and then it won't be counted towards the total coverage percentage. So on the design hierarchy window, we can also see how many percentage of coverage are being covered per instance. You can change this visibility by clicking right mouse button on each of the instance and then change coverage column visibility. You can select which type of code coverage that you want to see, or you can also switch on the hit count, miss count, and the total count as well. On the design hierarchy window, so we also have this design hierarchy window where we can switch from recursive to local. So again, recursive and local view, they are totally different view. So for local view, we only take in count of the local bins. For example, let's say from this DUT, we only take local bins from DUT. But if we change to recursive view, we'll take in count of the total bins from all of the instance under DUT. So DUT, @reg, and all of this. You can also sort the column by the total number of percentage coverage or any other code coverage that you want. So on the design hierarchy window, you can also exclude the whole instance from here by clicking right click here, and then you can exclude coverage here. Or you can also generate report for a given instance by using this export coverage report. And if you want to go into right click the DUT and then go to test analysis, you can find the test with list coverage. It will list out the test for you so that you can amend the test and come back with a better coverage. So in design unit window, you can also select a DU to change the scope and see the coverage for the given selected DU. And if you right click on this DU, you can also show instances to see the instance for the selected DU as well. So once you click that, it will have the instance name written out on the right hand corner. So looking for code coverage for a specific instance, so for example, wishbone, you can type it here. So once you type it wishbone, then it will bring you to the instance name wishbone. You can double click on the wishbone, then it will show you the code coverage outline for the instance. And it will also, from the code coverage outline, you can see the hit and miss bin with the coverage percentage being covered for each line. So once you double click on the wishbone, you can also have the source code view of the wishbone as well. So code coverage outline is something that it gives you a very detailed coverage analysis for the selected instance. So you can filter it based on coverage type and what it is covered, missed, or excluded items. So if you are only interested in the missed bin, you can filter it for missed items. And from the missed item, you can apply exclusion to the coverage by right-clicking and select exclude selection from the drop-down option again. So if you want to debug conditions instead, so you can, from the code coverage outline, you can show coverage on condition only. So it will show you the whole list of conditions that are being calculated in the coverage percentage. And then if you know which condition that are not being hit, you can filter out the line number and double click to see the details. So it will show you a result of coverage matrix where this input terminal TX burst enable is not being covered. And you can see it's not being covered, and it has row 1, which is not being covered from high 0 to 1. And again, you can also exclude this from this coverage details window. In terms of source code window, you can also see whether this coverage on certain lines are being covered. So if it's highlighted red, it's not being covered on some of the code coverage collection. So you can right click on the coverage indicator to exclude or see the coverage details. For toggle coverage window, so this is the one that is toggling from 1 to 0 or 0 to 1. You can view this by clicking again, view coverage and then toggle coverage. It will display all of the variables and their toggle percentage along with their transition counts. This window, we can also apply exclusion if you feel that signal is not very important for coverage collection. So for FSM coverage window, you can generate the FSM diagram to see the transition count and also the states. So from this upper window, you can see the FSM list with the number of state and transitions. So it highlights the link line of code in the source window, and you have the options to save this FSM diagram. If you want to exclude a particular FSM state coverage by selecting the block and then you right click, and then you can exclude selection as well. On test analysis and test ranking, so this is to find the tests with least coverage, most coverage, zero coverage, and non-zero coverage for the specified items using test analysis. So this test rank window shows the test ranking along with total coverage percentage for the whole design. So if you click on view again, there's a test rank window. You can see the list of the tests that you have and the total coverage covered by the test. On a different view, we also have a test plan tracker. So you can click on view coverage test plan tracker, and then we can analyze test plan coverage metrics here. So this shows the test plan and all its descendant sections with link of their coverage items. So there's a ranked test, performance test analysis, export, test plan summary using the pop-up window. So here you can specify how much of the goal you want for the coverage and the weightage and the link status and the bins and the total hit and the hit percentage. So test plan dynamic filters, you can also customize filtering options here. So in the filter, you can filter up on, for example, on primary attribute. You can apply it. So it will recalculate it for the applied filter on priority. So on exclusion, we have a few exclusion flow to follow. So one of it is to apply exclusion from the coverage window. Then the applied exclusion will be added to pending exclusion window. Yeah, please note that at this stage on the pending exclusion window, the exclusion is not actually applied yet. It's waiting for you to apply it manually by yourself. And how do we apply the exclusion is to execute coverage exclusion command from the pending exclusion window. Then you can check what did you excluded from the exclusion list window. then the coverage summary will be updated. On coverage exclusion GUI, so this window of coverage exclusion list, so you can exclude it from GUI. You can right mouse button on the source code or the window, and then you can exclude it by line, by DU, or you can exclude line for instance. Then the excluded bins will be listed in the pending exclusion window. So if you can see from this top window here, this is the pending exclusion window. So these are in the pending stage and it is not being applied yet. You'll have to use execute all commands or execute the exclusion individually so that the coverage will be recalculated. So if you want to waive out the whole module as well, you can do it by right-clicking on the design hierarchy. And then it will, double-clicking, it will show you the coverage outline. So if you want to cancel out the exclusion that you have applied, so once you have once your exclusion is being executed, the excluded coverage item will be marked as E. So for example here, this is being excluded. To cancel this exclusion, you can right-click on this excluded expression, and then it has the option to cancel selected exclusion. So this will add back the exclusion to pending execution. So this will be here, and if you want to exclude it again, you can just easily right-click and then execute this individual exclusion. So next we have coverage merge. So this is to merge multiple tests into a single UCDB. So for example, if you run a few tests with a few UCDB and you like to have the single merge UCDB, or you ran a few regression and you want to merge it into a single UCDB, you can use coverage merge. So for regression, usually we will use cover store, where it will store all of the UCDB with the related test plan name. So the corresponding coverage item should have an identical path across multiple UCDB. So you can use coverage edit to modify the path and then use, or you use adaptive merge if the design unit is slightly different. You can also use master UCDB to manage design changes. So master UCDB, usually we will use it to reflect the latest state of design. So let's say, for example, if you have already collected coverage few months back, and then right now you have a new design update on your DUT, so you can easily get the latest UCDB from your latest design, and then use your latest design as the master UCDB and merge it with the previous UCDB. So this will ignore anything that is not presented in your master UCDB. So anything that you have updated in master UCDB, it will only reflect the latest design. So how do we use this coverage merge? We use vcover merge and then your merge UCDB name with dash master with your first master UCDB and then your second UCDB that you wanted to merge. There's also another flow, we call it adaptive exclusion or adaptive merge. For adaptive exclusion, it's a typical exclusion flow where exclusion are tied to line numbers. The source code changes altered the file line information and render the original version of the exclusion do file useless. So for example, if you have a do file with exclusion tied to line numbers, but once you have your source code changes, then the line numbers does not mean that you are excluding the right line anymore. So in this case, you can use coverage exclude. You can use adaptive exclusion flow. So it will mark intended exclusion so that the exclusion commands can be applied to USDB with small design changes. So for example, if you use coverage exclude, and then your source is this .verilog file and the line number. So let's say in the updated source code, you'll see the line number 869. Right now, it's else statement only. So it doesn't make sense to exclude this else statement without any condition in it. So Cresta will provide a warning where the coverage exclusion command had no effect on some of the objects because no matching coverage data is found. Or if you add another command, another line of command, let's say for example, you add one more command line at 865, then your latest result of line 869 is the previous statement where it is a wrong statement in comparison to your first run. So how do we use this adaptive exclusion flow? So we have to enter VOP command with the adaptive arguments. So for example, VOP plus cover, this is to specify what code coverage that you want to use. So statement, FSM, and toggle. And then use adaptive, toggle ports only, and then your DU name, your top instance -O, your optimized DU. And then in vsim, you can just simply add -coverage option, and then you can generate adaptive exclusion report as a do file. So on coverage report, you can use -excluded, -adaptive, -file, exclusion.do. So the use model for adaptive exclusion. So for example, here, the only thing that we have to add is to add this -adaptive in VOP. And then at coverage report, we use -excluded and also again -adaptive here. On adaptive run, you can run the same and then you can apply the .do exclusion. So adaptive exclusion are added to the pending exclusion window for execution. And then you can execute the pending exclusion from the pending exclusion window. And on another topic, we have also adaptive merge. So adaptive merge, this is so that you can merge the data even there's a slight change of source code changes. So to do adaptive merging, the following conditions should be met. So you need to generate the signatures saved in USDB. So that is by doing VOP-adaptive as well. And then you use adaptive with vcover merge to merge the generated USDB using vcover merge-adaptive. So if either of these step is not fulfilled, then normal non-adaptive merge will take place. If you do a normal non-adaptive merge with a slight change of DU in both of the USDBs, the Questa tool will flag a warning saying that there's a slight change and the differences are not being merged together. So this is an example of adaptive merge. So we can use the same compilation command, but we add adaptive option to optimization phase. And then at vcover merge, we also add this dash adaptive option. So if you can see from two different versions of the source code. So the version 1, we start with always com begin. But in version 2, on line 10, we have reg A1. And then on line 12, we start with always com begin. So this is the type of small changes. There are also changes on line 17 where A1 equals to A here. So on a normal non-adaptive merge, the Cresta will flag an error or a warning on line 17 where it is mismatch between the both DUs. So the one that is without adaptive merge, it will not have this A1 equals to A being covered. But with adaptive merge, we can see most of these are being covered here. So for example, if your always block is different than this always block here, then all of these hit bins in this always block are not being considered when you merge the data. But for coverage adaptive merge, it will take in consideration of this whole block, even though there's a slight code change. So all of the coverage hit bins are also being merged in. So you can see the coverage statement is actually larger in adaptive merge compared to non-adaptive merge. Right, let's start the demo session as well. So this one, I have a lab case as well. Same, I'll need to have to trouble T to send out the test case to you guys. So let me send it over to T first.
Alo mọi người, em gửi cho mọi người cái file của bạn, gọi bạn ấy gửi thêm mọi người nhé. Mọi người vào cái link vừa nãy mọi người download về nhé.